Linear Guideway instructional video. Constant technology advancements have made people's lives convenient and comfortable. Everywhere in our daily lives, we can notice the effects of technologies that are derived from little inventions that lead to major advances. Transmission is one of them. Linear motion. What is linear motion? In a nutshell, it consists of moving an object from one place to another via linear movement. There are countless transmission products employing linear motion. Even if you don't fully understand the principle of transmission, you are certainly using it in your daily life. Furthermore, this principle is used in many kinds of machinery, which are used to produce other technology products that we also use in our everyday lives. Linear guideways originally evolved from linear bearings. But because the balls in linear bearings are not forced by a groove to move in a linear fashion, they cannot transmit torque, and they have a poor load-bearing ability and a short service life. The next evolutionary step was the ball spline. But ball splines can only be supported at the ends of cylindrical shafts, and they readily flex when subjected to a radial load. Because of this, they have poor rigidity. Thus, the linear guideway represents a further evolutionary advance. A so-called linear guideway uses rolling elements as the force transmission interface between a rail and a block, with the rolling element circulation system enabling unbounded back and forth rolling movement. The block is mounted so that it straddles and is constrained by the rail, enabling the block to follow the rail and engage in high-speed, high-accuracy linear motion. The rails can be attached to a flatbed at fixed intervals. They therefore deliver a high load-bearing ability, high rigidity, and high positioning accuracy. Linear guideways are thus currently the most common transmission elements. Linear guideways can be classified depending on the type of internal rolling elements. There are ball-type and roller-type guideways. To take this analysis even further, we can classify linear guideways according to their roller element and contact shape as Gothic arch 4-point contact, circular arch 2-point contact, and linear contact types. In addition, in the case of a 4-row linear guideway, when the rolling element's loading centers are inside of rail, this is termed a DF, double row, face-to-face type. The motion of this type of rolling element can be more flexible and has a larger allowable misalignment. When a linear guideway is installed, due to this feature, the blocks can still move freely even when there is a bit error on the bed where the guideway was installed. And when the rolling element's loading centers are outside of rail, it's termed a DB double row, back-to-back type. The rolling element's moment arm to resist rolling will be longer, and the guideway will still be able to maintain excellent rigidity even when a rolling moment is applied. In short, all kinds of linear guideways generally consist of 3 main elements: a block, a rail, and rolling elements. Apart from these, there are also several important components: circulation system, end cap. A linear guideway has 2 end caps attached to the block on either end and form a closed circulation path for the rolling elements. We can simplify this by saying they are pipes turning the running direction of rolling elements. Retainer. Before the block is mounted on the rail, retainers can support the rolling elements and keep them from falling off the block. Sealing device. Bottom seal. The bottom seal is mounted on the bottom of the block and provides a sealing feature preventing dust and cuttings from entering the rolling element's circulating path. End seal. The end seals are mounted on the ends of the block and provide a sealing feature preventing dust and cuttings from entering the circulating path. Basic static load rating. Let's illustrate this with a simple example. Suppose an athlete at a weightlifting competition gradually increases the weight on his barbell. The more the weight increases, the more the weightlifter's arms flex. If the length of the person's uplifted arms is L0, and the length of his arms after lifting the barbell is L, when L0 minus L equals 1/10,000th, we call the weight the basic static load rating. Therefore, when a linear guideway is stationary or in motion, if it must withstand too great a load or experiences an excessive impact load, there will be local permanent deformation of the track contact surface and the rolling bodies. If this permanent deformation exceeds a certain limit, it will prevent the smooth movement of the linear guideway. The basic related static load is consequently the maximum load causing permissible permanent deformation. It is defined, assuming a load with constant direction and magnitude, the static load at the instant when the total permanent deformation of the rolling element and track surface at the point of contact experiencing the greatest stress reaches 1/10,000th of the diameter of the rolling element. Permissible static moment. If a linear guideway must withstand an excessively large moment when it is stationary or in motion, this will cause local permanent deformation of the track contact surface and the rolling elements. If this permanent deformation exceeds a certain limit, it will prevent the smooth movement of the linear guideway. The permissible static moment is consequently the maximum moment causing permissible permanent deformation. It is defined, assuming a moment loading with constant direction and magnitude, the static rated moment at the instant when the total permanent deformation of the rolling element and track surface at the point of contact experiencing the greatest stress reaches 1/10,000th of the diameter of the rolling element. Basic dynamic load rating. Let's use an example to explain this concept. Suppose 100 runners are carrying heavy objects in a marathon, and they run the 1 million laps around the track at the same speed. In this marathon, at least 90 athletes must complete the full race, and fewer than 10 persons can drop out. The weight that everyone is carrying is termed the basic dynamic load rating. The basic dynamic load rating is defined as follows. After a batch of ball-type linear guideways with identical specifications have completed their rated service life of 50 kilometers, the maximum load ensuring that the rails, blocks, and rolling elements on 90% of the linear guideways have no fatigue damage, corrosion, or pitting is termed the basic dynamic load rating. The basic dynamic rated load is therefore used to assess the service life of a linear guideway. The larger the basic rated dynamic load, the longer the guideway's service life. Rated service life. Let's look at another example before we introduce this concept. 100 runners are participating in a marathon. As they run, occasionally one of the runners tires and drops out. When the 10th person has dropped out, this indicates that 90 runners are still in the marathon. The distance at which this occurs is termed the rated service life. Because of the great variability in linear guideway service life, there will be differences in the service lives of guideways from the same batch, even when they are used under the same conditions. This is largely attributable to the inherent variability of materials' fatigue characteristics. The service life of a linear guideway is therefore usually given as the rated service life, which is defined as follows. The rated service life is the maximum distance that can be achieved after which 90% of guideways from the same product batch, operating under the same conditions and with the same rated load, do not suffer any surface erosion. Preload and backlash. This can be explained using a simple example. When a thin person gets into a car, because there is empty space both in front and behind that person, there is no preload, but there is backlash. As a result, if the car brakes or accelerates suddenly, this thin person's head will bump around in the car. In contrast, a larger person that cannot enter the car and has to be pushed in by other people fills the entire interior space, which means there is preload but no backlash. If the car brakes or accelerates suddenly, the larger person will not bump around in the car. In the case of the linear guideway, When the diameter of the rolling element is less than the space within the track, backlash exists. The rolling elements may rock up and down or right and left as the sliding block moves back and forth, affecting the precision of its movement. When the diameter of the rolling elements is larger than the space within the track, there will be no backlash between the rolling elements and the sliding track, but preload. In this case, the block will not rock as it moves. Rigidity. Let's use another example. When a person leaps onto an empty bus, the bus will experience severe rocking. In contrast, when a person leaps onto another bus that already contains 30 passengers, the bus will not rock much at all. Rigidity is defined as the ability of an object to resist deformation. When processing or transport is taking place on a work platform, a linear guideway with backlash will readily suffer deformation due to insufficient rigidity, which will reduce the machine's operating accuracy. For good rigidity and limited deformation, a linear guideway with preload but no backlash will be helpful to the machine's accuracy. Processing of the rail. Heat treatment. Straightening 1. Drilling. Straightening 2. Grinding of reference surfaces. Grinding of bearing groove. Processing of the block. Drilling. Grinding of reference surfaces. Grinding of bearing groove. Assembly. Linear guideways are currently used in an extremely wide range of applications, including precision machine tools, various industrial machinery and equipment, general electronics and conveyor machinery, and many other uses connected with everyday life. Linear guideways have been available commercially for over 20 years. They've undergone numerous improvements and innovations, and many different types have been developed. The most common forms include the 2-row ball bearing type, 4-row ball bearing type, 4-row roller type, high-speed quiet type, self-lubricating type, and industrial robot. A 2-row ball bearing type design is ordinarily used for the smallest linear guideways that employ Gothic arch contact designs and can maintain excellent rigidity even in very small sizes. Thus, these guideways are very suitable for use in semiconductor manufacturing, medical and IC manufacturing equipment, and precision measuring instruments, etc. 4-row ball-bearing linear guideways with self-aligning ability are easy to install and are interchangeable, can withstand high loads, and offer superior smoothness and high accuracy. As a result, they are extremely suitable for use in machine centers, grinding machines, conveyor and automation equipment, electronics machinery, and general machine tool industry applications. 4-row roller linear guideways are designed for use in ultra-high load applications and employ rollers instead of ball bearings. With the linear contact between the roller and track, these guideways offer ultra-high rigidity, high stability, high load-bearing ability, and long service life. They are suitable for use in heavy machine tools and heavy transport equipment. In high-speed quiet-type linear guideways, a synchronous retainer called sync motion component is placed between the balls, ensuring they are spaced at equal distances. This prevents the balls from striking each other and causing friction, while helping to retain lubricant, thus ensuring the linear guideway is evenly lubricated and low particle emissions are generated. This type of guideway is suitable for use in high-speed machine tools, mechanical arms, and electronic semiconductor equipment. Self-lubricating linear guideways withstand longer maintenance intervals and offer the advantages of economic efficiency and reduced maintenance times. These guideways are especially suitable for use in electronic industry equipment and automation industry applications. Industrial robots combine ball screws and linear guideways and offer the advantages of quick assembly, high accuracy, high reliability, compact size, and excellent dynamic rigidity. Features such as a lightweight aluminum base, sealed dust-proof shell, and vacuum design make these products easily expandable. They are suitable for use in electronic industry equipment, automation equipment, and testing equipment. Little inventions, major advances. Linear guideways.